or some kind of an opening, and then around the outsides of it what we get is diffraction. So it's bending like this. Now if you're right behind it, we have what's called a shadow region, an area where you wouldn't experience any of those waves. Watch what happens if we decrease the size of the obstacle. So now the size of the obstacle is around the size of the waves. We decrease the size of that shadow region. And so by matching the obstacle or the opening to the wavelength, we can get more diffraction. And so let's do a little PHET simulation of that. So what we've got here is we're generating sound, and those sound waves are moving out. And then along this dotted line, we're actually graphing what waves make it. And so we're putting a wall between the speaker and the right side. And you can see that there's a lot of sound on the left side, but none of that sound is making it to the right side. So we're graphing along this dotted line. Watch what happens as we start to decrease the size of that wall. So as we decrease the size of the wall, you're starting to see diffraction on this side and more diffraction on that side. Now what would you hear? You'd start to hear sounds. It'd just be quiet sounds. But you can see that we're getting waves right here, so you could still experience those sound waves as they're diffracting around an obstacle. And as we make that obstacle smaller and smaller and smaller, we're getting more diffraction. And so if we're looking at light, the wavelength of light compared to sound is so small that it's simply not able to diffract around that corner. Application of this, if we're looking at radio waves, let's say we have shortwave radio signals that are moving out. That means shortwave, that they have short wavelengths. And let's say your house is on this side of the hill. So as those waves move out, they're not diffracting enough around here to make it to the house. What does that mean? You couldn't pick up those shortwave signals. So what would be a solution that we could have? Well, we could put another relay up here so it could send you those signals. But if we're looking at long waves are going to be diffracted more readily, and so they're not going to experience that problem. And so did you learn to predict or explain the ability of waves to transfer energy around corners or through openings based on their wavelength? I hope so, and I hope that was helpful.